Thank you. Thank you. I am a retired scientist, and full disclosure, I'm working part-time with the Global Methane Hub as a science advisor, and I find that extremely rewarding. So, and when I'm not doing that, I'm just, baking cookies and looking after my grandchildren and all those fun things. Welcome to our panel this afternoon, the last panel of the day, and we're going to talk about existing and emerging methane measurement technologies. So I think, for me, reliable methane measurement is really fundamental to everything we're trying to achieve here. So it's an important topic. But I think everyone in this room and online would agree with me that measurement is not straightforward. We have a lot of different techniques that give us a lot of different kinds of information. They have their strengths, their limitations, their costs, their practicalities, et cetera, et cetera. So I think it's really important to understand the technologies and where those limitations are, and which technology is best used for the question at hand. So it's matching the technology to the question that we're trying to answer. So look, today we're very fortunate because we have three very excellent speakers on this topic. And together they will cover some of the existing technologies, and we're going to hear about some emerging technologies as well. And I really hope that they will talk about some of the learnings that they have achieved in their own personal experience, their own research. Because I think it's really important to understand as a group where we are in terms of measurement technology and what are we lacking and what do we need to do to improve our methane measurements as we move forward. So with that, then, I would like to introduce our first speaker, who is Dr. Sara Place. Sara is, let me get her bio here. Sara is she's an associate professor of feedlot systems at AgNext at Colorado State University, where she focuses on sustainable livestock systems. She previously served as a chief sustainability officer with Elanco Animal Health and as a senior director for sustainable beef production research at the National Cattlemen's Beef Association. Sara brings a unique experience to our panel this afternoon. She has a lot of work done on pasture animals and methodology. So with that, Sara, we look forward to your 8-minute talk.
Thank you, Karen, for the introduction, and thanks for the invitation to be here and speak today about this topic. All right. Okay. So to get started, I'll just kind of give a very quick overview of more of like the basics of methane measurement, and then hopefully we'll kind of cover some more of those methodological questions that Karen alluded to that we've been covering at Colorado State as we go through the panel questions. But just to start, when we think about best measurement strategies, this is one of those things we discussed in kind of our pre-call of thinking about what is the best strategy. And this is difficult because there's so many different ways to measure or to estimate methane emissions today. And so it can be hard to know, especially if you're, say, a company in this space or someone kind of new to the field, of what are all the differences between all these different methods. And just some pictures here, right, of course, of the green feed, which has been mentioned before. Sniffers, which that picture there is kind of our current setup where we're testing a sniffer system at our feedlot facility. Or this, another way of looking at this is measuring from a whole facility, right? Open path lasers or dual column spectroscopy that we're doing today at CSU. We can think about in vitro systems, right? Trying to actually think about just the rumen fermentation processes that are happening in gas production, or head boxes. We saw those head boxes earlier, right, of measurement at Colorado State. There's lots of head box systems or whole animal chambers. There's a whole list of things that we can do, or models, as we just heard about, of trying to estimate methane emissions. So when we think about which one of these is best, it does depend upon the research question. This is just a little bit of a summary, right? And there's a great paper from Luis Tedeschi and others in 2022 that kind of goes through a lot of these, and I've just modified that a bit for some of these ones that were on the prior slide, of thinking about how we may estimate those emissions. And there's differences. There's differences in the cost of operating, the complexity of operating, what we're actually measuring. Are we measuring an individual animal? Are we trying to simulate rumen fermentation, again, with like an in vitro system? Are we looking at whole facilities, right? When it comes from, say, open path lasers and using inverse dispersion modeling to try to estimate whole facilities. And each one of those may have a different question, right? Maybe for a whole facility, that makes a lot of sense for measurement, reporting, verification of a carbon protocol, for example. We may want to look at before and after. But if we want to look at genetics, which has come up several times, we need to know about individual animal variation and phenotypes. Obviously, a whole facility measurement doesn't make sense. So hopefully that kind of connects there in terms of there's different measurement processes that are fit for different purposes. The other key thing here is I've kind of put this little category of what is measured. Are we measuring just the concentration of gases, or are we truly measuring what we can think of as flux? And just to further explain that, right, just more of a 101, if we think about what we're measuring, concentration is truly what the abundance of the volume of gas is, right? So say we're measuring, take an air sample, we're measuring parts per million of that methane. It tells us a snapshot of how much methane is there, but it doesn't necessarily tell us how much is being emitted, say, from a given animal per day. That's getting more towards flux, right? And when we measure flux, we have to know, right, our mass or our volume of gas that's being produced from that animal or from that area if we're doing whole facility measurements per unit time, right? Which sounds fairly basic, but I know I'm sure others have encountered this as well. In Colorado, we have a lot of oil and gas production, and sometimes we'll have companies come to us that say, hey, we have a really good detection method for methane, right? That can tell us really precisely the parts per million of methane. That doesn't really solve our problem when we want to know emissions per animal per day, right? Because we know that animals are leaking methane, right? We're all aware of that. So we don't need to just detect it. We need to actually quantify the differences, say, within diets or any of those things. So very simply, right, if we think about what it would be one of those research questions, what if we have, Cam the ram here that we're trying to think about how much methane does that animal actually produce per day? And we think about some of those classic ways that we actually measure methane emissions, very simplified, right? If we think about a respiration chamber, those key components, we of course have some sort of inlet where we're measuring the incoming air and the concentration of methane or whatever gases are of interest. We're measuring the outlet and the actual concentrations there. We're looking at that net concentration and actually measuring the flow rate, right? And having to do all those things with precision, right? And so this would be that idea of a whole animal chamber. Many other of our methods are kind of modifications of this. Even if we think about, say, a green feed system, instead of an animal being truly enclosed, an animal is coming up to a feeder that's open-sided, right? But the principles still apply. We have to know background concentration, what's being emitted from the animal, and the flow rate, right? We just have to make sure we're generating a really fast flow rate to make sure we're actually capturing everything that animal is emitting. So again, those are those kind of basic principles. We have to know those things that we're actually measuring. And the key thing there, just again, very simplified, is any system can be on paper good, but we also have to make sure we're doing a good job from a basic principles of calibrating those systems. How well are our analyzers actually detecting known amounts of gases and doing recoveries, right? So we heard that earlier from Terry talking about using, right, burning ethanol from a standpoint of doing a recovery. There's many ways we can do that. But when we put a known amount of gas into a system, what are we actually getting out, right? And that's one of those key things that's important. We see that a lot now that folks are reporting that in papers, and that's good, right? We need to make sure that we're also checking our whole system accuracy from that standpoint. And then just very briefly, so we do a lot of work with green feed devices and those open head boxes, if you will, those automated head chamber systems. A lot of that is because we are interested in animals in their kind of more natural production environment, whether it's in feedlot pens, not restricted, or if we think about in grazing situations with beef cattle, which is where most of the methane is actually being produced, not just here in the US, but around the world, right? Our grazing animals are extensively managed animals. So with those systems, one of the things to think about is again, back to our research questions, how many of these visits to these green feeds do we actually need? And that may vary depending upon what our research question is. What I have here in this table is just some different publications and a couple of ours from our group at the end there from those Vargas publications of thinking about how many spot samples do we need to have a good, basically methane phenotype of animals, right? Back to the genetics discussion, if we're going to assess how animals rank within a cohort, how do we actually quantify that, right? And you see a range there in terms of what those different visit numbers are. And then just a disclaimer of that, right, of kind of some of those things at the top, of the table of what we're trying to capture is that diurnal variation that's potentially there of methane emissions, right? So especially if we're feeding animals, say once a day, we'll get a very strong diurnal pattern or low points and then high points of methane emissions throughout the day. And so we want to make sure we're doing a good job being representative and when those animals are being sampled throughout a 24-hour period to represent that. And when we think about how many visits we need, it also depends on, with a green feed machine, how you have the machine set up. How many visits can they make per day? What's the spacing of the visits? So while this table is presented here, keep that in mind of it kind of depends upon your setup as well, right? In terms of what the right answer is. And how many days you need to phenotype an animal depends on how frequently you get those animals to visit. In our case, if we think about our 55 visit threshold in confinement, usually we can achieve that within 20, 25 days in our setup. So all that said, hopefully we can kind of discuss this more, but that's just a brief overview of getting us started when we think about measurement. So thank you.
Okay, our next speaker is Dr. Mutian Niu. Mutian is an assistant professor of animal nutrition at ETH Zurich's Institute of Agricultural Science. His research focuses on ruminant nutrition, methane mitigation, heat stress, precision livestock farming. Mutian's doing some really innovative work in the area of methane measurement and comparison amongst techniques, and he will give us a short synopsis today on what he's up to. So thanks.
Thank you, Karen, for the kind introduction, and thanks for the opportunity to bring me back to Davis after my PhD for 9 years. Well, again, very nice intro, Sarah, for also my talk. So today, opposite way. Yeah, so here's my talk. We talk about what do we deal with data, how do we deal with the data, and reliable standardization of data, which is the foundation of accelerating methane mitigation research, but also implementation farm. I'll bring 3 measurement techniques for methane and also our emerging technology we talk about. Actually, we already heard from Sarah about these 3 technologies, which cover 2 case studies. I'll bring respiration chamber, green feed, and sniffers. And they all have pros and cons, measuring fluxes on the left 2, concentration for methane sniffers, different throughput, and also different measurement conditions, frequency, and etc. So the first case I'll bring is a study we did in our group about methane measurement from green feed versus respiration chamber. So the study, by the way, I'm a nutritionist, so very briefly of the design. So we have 16 cows that we place in a normal basal diet, and we measure 3 days, 3-hour interval in green feed, followed by 2 days in the chambers. And then we introduce 4 different diets, mitigating, trying to bring the range of methane, all incorporating 3-NOP, plus some of the other additives, pretty low amount. And 21-day adaptation, followed by similarly 5-day measurement, green feed and chamber. So the idea is really to create a wide range of methane and to see how robustness of those 2 technologies, one versus another. There are a lot of results. Given the time, I just want to bring a very quick, again, from mitigation strategy standpoint, when we look at the mitigating effect of 3-NOP, we're actually from the treatment level, really comfortable, really confident to see there between the 2 techniques, we don't see a significant difference between the 2. However, when we look at these 2 charts, which showing the emission measurement of of a chamber against green feeds for individual animal on the daily level, we can see actually there is a significant slope bias in there. So on the left, we are showing just the raw value. On the right-hand side, we have seen the marginal residuals taking out the fixed effects from the two measurements. So from there, we can think about where the bias come from and what factors should we be thinking about and controlling, because this is really important. After conducting the experiment, the data is fixed, right? So we have to think about these things prior to the experiment being carried out. Which led to actually, this is one of the ongoing project, really great effort by 6 Institute, which I'm not going to read the name, across different area in the world. We're trying to collect a large data set with the idea to bring standardization, some recommendation to the user for in this case, for green feed. But I hope this can also be carried out to some other spot sampling technique for measurement. Just to give an idea, we look into, for example, when we think about before experiment being conducted, should we think about the pellet? Should we think about if I have 40 cows or 60 cows, should we place 1 or 2 or 3 units in there? And also, after data being collected, how do we handle the data? So if you have a green feed data, feel free to contact us. The second case I want to bring is sniffers versus green feed. So we have heard a lot today in the earlier discussion on breeding low-emitting cows. And we know from Brigitte and also colleagues in the panel, is actually most of the data, not all, but most of the data using for genetic evaluation, breeding low emitters are being collected from methane sniffers, giving the high throughput nature of sniffers. So again, please refer to Brigitte's slides on this, but just to show you, this is actually not just one country, but many different areas, different countries are doing this. And one of the important setup is taking advantage of AMS system by installing a sniffer in the AMS, in the milking robots. However, when we look at this data from different studies, the sniffers are, at least in the earlier days, I think now maybe it's more standardized already, are installed in different locations. So this is just one snapshot of showing there are factors we need to consider, such as the location of the inlets in the AMS. So we came up with another study where we installed 9 sniffers in one AMS. This is collaboration with the CLOC, actually. So our idea is simple. So we believe there will be some discrepancies, depends on the location of it. But we also are very curious to see whether the ranking, what would be the best location. So you probably have a guess which location among the 9, which is 15 centimeters apart from each other, give you the best data. So let me take you through quickly. This is inlets and where the gas will be flowing among these 9 sniffers. And then if you look at the distribution of it, most of them, so the top 9 are the 9 of them, and the bottom is our benchmark, which is green feed. So we can see among the 6 cows, I think there's 105 cows, 2 minutes, we can see most of them, especially on the 2 edge of them, are actually having a red school distribution. And 2 of them, number 5 and number 8, naturally in the middle, are having relatively aligned distribution compared to the methane. These are the same animals, again, measured by 2 systems. How about the ranking? So I'm not a geneticist, but I'm imagining we want to select for, we want to have a higher Spearman correlation here. So we actually conduct Spearman correlation. We can see number 5, which is the middle, and number 8 gives us to the highest, so a little bit over 0.5 correlation coefficient. So of course, all models are wrong, some are useful. We are very subjective when we look at the statistics. So it's up for us to decide, is this a strong or moderate or moderately strong coefficient between the 2? But again, just want to emphasize, even the location of inlets in the AMS for sniffer placement play a role. So the standardization of the other factors also will play a key role in there. All right, so this is my second case. And the last, I want to take the opportunity to introduce something actually really come from the measurement of methane from our methane mitigation research on axolomics. Actually, it measures methane, but much more. So very quickly, I want to introduce this. So we call axolomics, stands for axial breath metabolomics. So what does it do when we measure methane? There's also a lot of other compounds, gases are coming out of the rumen, also the lantus. Actually, I had been in Switzerland for 5 years. For those who come from Europe, you can talk about the licensing application, how difficult this can be, our colleagues here. So this is one of the challenges I was facing. So I was not able to cannulate cows as much as possible. I was not able to do tubing easily. So this is actually my way out to look into the axial volatile fatty acid profile. So this is our starting point. So this is basically VOCs, amount of VOCs, volatile organic compounds, where we're looking in the axolomics. So very briefly, I want to show you this is something we are familiar with. On the top, we have the acetate. On the bottom, we have the propionate, molar proportion, diurnal pattern, 3-hour interval from our benchmark, which is ruminal profile versus the axial profile. So you can see align quite well without interaction between time of day and the two measurements. We also look at the emission, the acid propionate ratio regression. I actually have a very good no slope bias in here. So really bring us the confidence in better monitoring non-invasively the profile in the rumen. So not only the methane is important, but also understanding why the mode of action, what are being changed in the rumen fermentation is also important. What's more exciting is besides the 3 or the 6 fatty acid, short-chain fatty acid, we also observe over 1,000 volatile compounds. And that's actually the huge potential we are looking into together. Another project coming up, supported by Global Methane Hub. We're looking into not only the carbohydrates, these are more the carbohydrate-related fermentation, but also the other nutrients and the inhibitors. Okay, that's all my information. Better data will bring us forward more strongly. And yeah, let's do it together. Thank you.
Okay, our next speaker is Dr. Joe Jacobs. Joe is a research director with Australia's Department of Energy, Environment and Climate Action. He leads a research program on dairy systems and methane mitigation, and he also leads the work at the Ellenbank Victoria Smart Farm. But Joe contributes, he's got extensive experience measuring methane in pastoral systems, and is very familiar with some of the practical challenges of obtaining reliable data in pasture systems. So I think we're looking forward to hearing what he has to say in terms of how that may help us. Thank you.
Thanks, Karen. I'm not sure how many caveats I now want to put around what you've just said, but we'll see how we go. So the first thing I'm going to note is I've also put 2 co-authors on here, Richard and Aidan, because they are exactly the people you've just spoken about, Karen, the people that know the methodology inside out. They're the guys on the ground doing the work day in, day out. So I would be very remiss if I didn't include them here. That view there is the one from my office. I hope that makes you all feel very jealous. So that is our pasture-based systems that we operate in year-round. So what I'm going to talk about is very much how do we measure methane in those pasture-based systems with all the associated challenges that Karen just alluded to. Similar to the previous speakers, I'm just going to take a bit of time to really talk about 3 of the methods we use, which are the chambers, SF6, and green feeds. The 3, I guess, go-to methods that are validated and accepted as methodology to use for, particularly if we're looking for output numbers, yield numbers, intensity numbers. And just a bit of pros and cons on each of those. And I think, Sarah, you already covered some of these, particularly for the chambers and the green feed. These are just our views. I'm sure there are many other personal views on pros and cons of those. Obviously, the respiration chambers, the gold standard, highly accurate, the go-to, but have a lot of challenges, least of which is that real big change in behavioural patterns of the animal. For us, getting it through animal ethics, I've seen progressively over probably the last 15 or so years, we've moved from 5-day measurements to 3-day to 2-day measurements. Still retain the confidence in doing that, but have been pushed that way very much by our ethics committee. You either work with low animal numbers, rely on the high accuracy, or you have very long experiments. least of which is training animals to that environment to minimize those behavioral challenges. The SF6 in the middle, we can use it across a range of environments. Really happy with that fact. Data is comparable to chambers, and I'll show something in a moment along those lines. And in effect, more data for less cost. Obviously, there's a lot of cons to them. Ultimately, you're putting a perm tube with SF6 in that's got a finite life of real usability to it. It's a classic Michaelis-Menten decay curve, so there's only so long you can do it and have confidence in the numbers. And there are lots of potential error points, and it's probably the reason why a lot of people steer away from the methodology. But I'll loop back to Richard and Aidan and how invaluable they are for my team in implementing this methodology. So error points, perm tubes, obviously, canister vacuum, sampling rates, and there's a few others again, which I'll come to. And then I think, Sarah, you covered those with the green feeds. Just on the modified SF6 method, certainly we've been very fortunate through to Matt Dyden, and you can just see him listed in the bottom of this slide. Did his PhD across, started off in Dublin and finished up with us. But really, it's interesting how a whole PhD can be focused on just getting this methodology right. So things like on animal backgrounds. So traditionally, there would have been sentinel canisters around the facility, hopefully covering the background. We've certainly seen, and I like to say when we get visitors, Ellie, as we affectionately call our generic dairy cow, she can be a very social butterfly on one day with lots of animals around her, and invariably her background is higher, to being that I want to be on my own day, and her background is lower. So having that individual background is really important for the method. The inclusion of an orifice plate, a restrictor in effect, with a laser drilled 5-micron hole that allows us to retain vacuum for nearly those 24 hours to get a consistent flow of gas into those evacuated canisters. Uniform initial vacuum, narrow range in SF6 release, and understanding decay over time. So having those perm tubes sitting in an incubator from the same batch that was made at the same time, repeatedly measuring those and knowing that release rate is changing over time. What I want to move on just for the rest of this presentation now is a new opportunity. So we were approached by Zelp, and Francisco, you're somewhere in, there you are, Zelp, just to see if there was an opportunity to take the development of this technology a stage further. So in effect, from a confined system with lots of testing, to one that was more an outdoor environment where animals could truly test the technology. The points that are up here on the slide are those listed by Zelp. So they're certainly not my words, they're the ones that Zelp have provided. What I will say is it allows continuous emissions pattern over the course of the day. Cows can be in a natural environment. There's no need for perm tubes, so that's a big tick if it works. And no need for specific visits X number of times a day to a given location. So what we were able to do is run a trial earlier this year over, in effect, it was a 52-day period. So there was a 12-day adaptation to diet. This was a hay-based diet in our auto feeder system here. 12 days to adapt, then 40 days of background measurements with the green feed machines, and there were three green feeds across what started with 40 animals, ended up with 38 animals across the trial. Midway through that 40-day measurement period, half the cows were fitted with SF6 and half with Sense. And then days break, 5 days, days break, and those animals swapped over. So those that had SF6 went to Sense and vice versa. After much discussion with the Zelp team, we agreed we wouldn't try and put all the gear on the same cow at the same time. Personally, Francisco, I think we could have done it. I think it would have worked. So you can just see in the top picture there, that's, I guess that's the perfect picture, hiding the person's face, isn't it, for anonymity? But that's Aidan. And fitting the gear on, I must admit, Francisco, we had some reservations the first time we fitted it on, but we were actually surprised how easy the system did go on. and how easily the animals accepted having the gear on for that period of time. Having said that, and we were very fortunate to have two of the ZELP team on site, two of the technicians, Tom and Ricky, which was great because I guess the best way to describe it is the girls really did test the technology. I think it wouldn't have been a day if something didn't get broken by one of them. Probably the biggest challenge we found, and you can see in the picture up there, the two prongs, for want of a better word, that draw the air in. We feed a loose grain with a bit of canola in it, and we had to clean them pretty regularly. So toothbrushes become our best friend, just giving them a clean off every day. They certainly tested it. The equipment below the neck got regularly immersed completely in water troughs and survived and kept going. So I think we learnt a lot, and I think, Francisco, your team learnt an awful lot as well. And I think you've got an updated version here with you, so I'm sure people will be interested in seeing that. What I'd just finish off with, and I think this is the last one, is just working through the numbers here. We got a lot of good SF6 data. We got a lot of good green feed data. I'm not sure, Sarah, it was you or Mutian talked around visits. We had a good number of visits, particularly in that 10, 11-day period in the middle of the trial. And we got good data from the sense animals. What I will say is this is one of the horrors of being asked to provide the slides a couple of weeks early. These numbers are out of date. So the SF6 number's right, so that methane output of 511, and these animals were eating just over 24 kilos. So if we look at our inventory number, that would tell us the number should be just shy of 500. So I'm pretty comfortable with the SF6 number. The sense number is 476, and the green feed number is 473. So they all stacked up pretty close. One of the challenges we're seeing with the data at the moment is for an individual animal, across animals, there's not a consistency in one method being higher or lower. So that's where we're working through now to really understand the variation in the data, the sensitivity and accuracy of this. But safe to say it's a work in progress. And I'll leave it there. Thanks, Karen.
Okay, I'll ask all three to take the floor up here, and yeah, we'll do the Q&A. So please, in the audience, if you have some burning questions that you want to ask our speakers, just on here. Yeah. Yeah, is the mic working? Yeah. No. Yes. The mic work? Yeah. Okay. Okay, well, I think we had some really good presentations talking about the different technologies. And while we're waiting for the audience to get their questions in, I'm just going to start with a general question for the three of you, maybe. We often talk about matching the technology to the question at hand, right? Like whether you're looking to do phenotyping of animals or on-farm verification of a mitigation technology, or if you've got a new feed additive and you're trying to figure out if it's working. What can you say about that in terms of how do you go about matching the technology to the question at hand? Any thoughts on that?
I might make a start on that. Yeah. And I guess the good example I always use is and the example will be if a company comes to us and they're developing a new additive, it really is what's the question they're asking. And if it was let's say it's a bromoform-based product, they may be as much interested around the pattern of emissions across the day in relation to the feeding system, which would err more towards, say, the respiration chambers, which are capable of giving you those patterns. If it was, we've done a modification of an existing additive, we just want to know, does it reduce methane? I would actually steer them away from the chambers towards some of the other methods that are really cheaper to implement and have maybe more animals. So there was something that came up earlier today around repeatability and power analysis within data. So that's a simple example, I think, Karen.
And or of course across different production environments, right? So if it's wanting to test something in more of a grazing situation, or we have those conversations too of course always that challenge with respiration chambers. They're great, but then definitely the animal's behavior is altered and they're not maybe eating at the same rate that they would be on a commercial feedlot, for example, right? So that's one of those considerations as well of the degree of manipulation that we're having on the animal's normal behavior. And that may influence how we make that choice as well.
Mutian?
Yeah, I'm kind of in line with my two colleagues here. Also, trade-offs, I would say. So, what will be the throughput we need? We need thousands of data, or we need, for example, the AFSA approval, which mentioned we need the duration, and then do we have enough power given the animals, or need 2 years of study to meet in those? So, we have to consider all that when we discuss the mitigation strategy development.
So I think at least Sara and Mutian talked about a little bit about concentration versus flux, right? So we know with lasers, for example, or with the sniffer, you're measuring concentration. So first of all, is there any relationship between concentration and flux? Like could concentration be an indication of flux?
Yeah, if you talk to physicists, they will laugh at us, right? So
They will what?
they will laugh at us.
Laugh. Oh.
Yeah. So again, we'll come back to the trade-off, right? So we look into ranking, which is why we look into ranking, because we also have team, Francisco and also team in Wisconsin, and others presented earlier today. Also, Zoeda's colleagues, they've done also a lot of measurements. So do we have such capacity? And then what is the goal to achieve? Looking at different production system, different breeds, different species, for example. So yeah, I think it's along those lines.
Yeah. So, and oftentimes those methods are looking at, say, maybe the methane to CO2 ratio, right, to try to infer flux from that using some sort of base data set, usually from a chamber, from a green feed system, right? And so that's one of those considerations, and that's central to that trade-off of the earlier discussion about genetics, that reality of like phenotype is king, and we need to have this huge number of animals to make a lot of that phenotyping work. That's always that question of how much accuracy are we willing to give up with these type of methods, such as a sniffer, where maybe it depends on the placement of the device, for example, versus just the number of animals that we can get through the system. And I think that's kind of the key thing of thinking about how much money it costs to collect that phenotype, which can be quite expensive for some of our methods. And we have to weight that against the reality of the accuracy. But I think that's where genetics and ranking, we may have a different tolerance for concentration data compared to when we're trying to quantify differences in actual treatments that we're delivering to this animal. Then we may say, well, flux is what we need, right? We can't really infer this from concentrations.
I guess the only thing I'll add to that is sniffers ain't sniffers. So by that I mean we've been fortunate. We've got a range of sniffers in each of the feed bays in our dairy, 25 a side dairy, so 50 sniffers times 2 at the moment in there. One's a passive, one's an active. We get very different concentration data from them. Then we also see over a milking bout, let's say the 15 minutes they're in there to eat their grain, get milked, that concentration changes remarkably over that period, depending on, as you said, Mutian, head location, airflow through the dairy. So there's a lot to work through. If we then try and relate that when we're running, say, an SF6 experiment, and we try and correlate the data, we've struggled to see correlations between an output and a concentration at this stage.
What just reminded me, actually, the correlation is that correlation what we need. Actually, there are variable results showing there are moderate or weaker correlation between sniffer-based concentration versus fluxes. So, but is that what we need? For example, if we also modeled the diurnal pattern using sniffer and green feed, they are highly correlated. We talk about over 0.9 Pearson correlation. So for me, I'm very curious about diurnal pattern. Relatively, that's feed a go. So again, back to Karen, your question, what is the objective and what we want to achieve. So,
There's quite a few questions related to the green feed system. So I'll just start off asking, like in a pastoral situation, because I think, Sarah, you talked about how many visits do you need and how that equates to how many days. But does it matter, like in a pastoral situation, the animals may be visiting the green feed once or maybe twice a day, and it might always be at the same time of day. So it doesn't necessarily, even if you were to have 1,000 observations, it's always at the same time or plus or minus. Is that a concern with the grazing measurements, or over time it doesn't matter? What do you think?
Yeah, so that's a great question. And that's kind of back to the reality of even within the green feed system, you can set them up so many different ways, right, that it's always hard to be generic in the answer, right? So I'll just say specifically for us, just for simplicity's sake, we almost try to keep them always the same, where we have setups of continuous exposure and the animals can visit at 4-hour intervals. So we're trying to force the animal to visit at different times of day. That can be difficult in the grazing situation because you're usually putting your green feed next to every attractant known to man, right, to try to get them to actually use it, right? Next to the water, next to minerals, whatever it may be, to try to get them to come. And just observing the animals, right, we see that even some of the more intensive grazing that we've done, the animals will all kind of come together and they'll visit. And then if you're especially the low-ranking animal on the behavioral totem pole, you may be kind of pushed off at the end, right? So it does matter. And part of that diurnal pattern is making sure at the end of an experiment or even during, you're looking and checking to make sure you're not, everybody is visiting at 10 a.m. and that's all you have, right? We've asked that question of our data afterwards from grazing situations of saying, should we time bin the data or should we just take a straight arithmetic mean? For the particular data set that we looked at for that, there was no difference if we just looked at the straight arithmetic mean or if we did a bunch of pre-processing of the data to look at time binning. But those are the type of things that people need to really think through when they're looking at their own data sets.
Anybody else want to comment?
I just want to add, I'm not a grazing expert, but really interesting here about the 4-hour interval. We just did another project in the project I'm going to mention about. We're looking at different intervals and relative, what's the starting point, if we can control relative to feeding. Of course, grading system is very different. And then when we look at the in-house data or freestyle data, for example, we talk about repeatability, Joe mentioned earlier. At least we need 1 week or 2 weeks data to reach over 0.6 or 0.7 threshold. Well, yeah, that's why the visit you explained the table. Yeah, that's quite big.
So there's quite a lot of interest online here about the green feed system, and I would just generally say like transparency in terms of data and how data are obtained from the system, how they're interpreted, how they're analyzed. Does somebody here want to talk about that? Is there some concern about transparency, or we just accept the values that are given to us in the papers? Or
yeah, I think that's important, again, just as us as scientists, to make sure that we're reporting all relevant things, right? So folks can interpret what they're looking at with that in mind. And part of that is back to the basics of making sure that we are running calibrations, running recoveries, right? With green feeds in particular, there's been upgrades where they have now onboard auto recovery systems and things like that. But I think one of the things that's important is maybe for us in the scientific community to make sure we're reporting all the different features of these machines, because we've definitely seen that with older models side by side with newer models. When we had different gas analyzers, you may get different means, right? And so as we've phased out some of those older units, we've had less of those challenges. But I think that's one of those things that for us, we definitely bug CLOC very often. So if we ever have any questions, we ask them directly and we get to the bottom of it. So that, I think that's the nice thing about the company is they will respond to the exploration of what is going on, right? And that's what we appreciate from that standpoint, always with our partnership with them.
If I may just add to what Sarah said, it's really important we document the details of those when we write papers for researchers here. Like how many, I mean, when we think about it, how many of us cited the method, at least the Tysdal method, we reference Ristoff 2015, similar as described as Ristoff 2015 without discussing details. So I've done that. So think about it. So it's going to be different, not exactly the same. So it's important we document, and then eventually even the chemical composition of your palette is important, which we don't know actually. So yeah, that's why detailing.
Do you have anything to add on that, Joe?
Look, I think the only thing I'll add, and this has changed slightly in recent times, where CLOC have now got people on the ground in Australia, in New Zealand on a more regular basis, but until recently that wasn't necessarily the case. So we were happy to get under the hood, under their direction, and understand some of the machinations and workings within there. So I think that's helped my team understand them. I think the other thing, implementation in intensive rotational grazing system, I think is a challenge. How many moves of the green feed do you need? You know, if we've got a minimum of 2 new paddocks a day, but invariably we'll split those paddocks. So they've sort of got to get used to where it is each time. Will they visit? Won't they? Yeah, it's a challenge.
This question's for you, Joe. On the new ZELP technology, the Sense technology, you made a comment about how you had technicians on site and there was something happening pretty much every day. Was that the cows were trying to remove the device, or was it just clogging up with water and dust? Or can you elaborate?
Yeah, there were combinations. I mean, I think we got to a point where we were becoming quite meticulous with cleaning the baffles. They may not have needed it, but I think just to really test the methodology, it was important we did. I think the other part was cows like to play. They've got something on them that's new. They'll find different ways to test and break different components. And I think that was important because the technicians did learn a lot. And my understanding is since then, there's been a lot of upgrades in how the gear is attached that have been learnings from that. So yes, it was great to have them. It was important to have them. Will they always need to be there? No.
And so in terms of the data, you had the SF6, we know you get grams per day. You get one number per day per animal. With the green feed, we have visitations, but with the new Sense device, were you able to get data? Could you drill down from grams per day? Could you look at like 2 or 3 or 4 hour blocks?
We could get blocks. And I think, Francisco, you might have to help me there. There you go, 6 hour blocks. But I think that's something we can work on if we want to drill that down further.
We could look at diurnal patterns. Yep. Okay, so there's more questions about sniffers that we need to talk about. Like Mutian, you talked about depending on where the device is positioned in the head chamber, you had different concentrations and what have you. What impact would that have on like ranking animals as high and low methane animals? Like, because presumably on one visit they may be putting their head this way, and the next visit they'd be over here. And so over time, does it matter?
It definitely matters. I think, for example, if you think about cow comes to one side of the AMS, so is the cow against the sniffer position against which side matters, and then even vertically, is this middle or the bottom middle is the best? We actually have similar issue in the bottom one getting clotting, just like what you experience in the Sense. So yeah, it's really variable, and we have to think about what will be the best. And then, I mean, that's how actually why we want to do that project. It was really curious about is this concentration high because of what reason? And obviously, it's observational study, so there's a lot of speculations, and of course, kind of underpin the complexity of factors we should consider in there.
Okay, there's some questions on animal behavior. So to what point does the methane measurement technology alter the behavior of the animal, and what impact would that have on the measurement? So for example, in a chamber, the animal's in a stationary position, doesn't move a lot compared to a green feed system walking around in a paddock. Do you think behavior matters, or?
There's obviously energetics associated with walking and grazing as an example, but the other counter to that is if intake is consistent, so energy nutrient intake is consistent, you should have reliable data. I guess the question is if behaviour is impacted to such a degree that intake changes, which then results in lower fermentation, lower milk production, you're having a negative influence that you can't say is a result, let's say, of an intervention. So I think there's that overlay as well, and that's part of the reason for us. We've had ethics keep on our hammer the whole time about reducing the time, which in many ways has been a good thing. The data's still reliable with 2 days in the respiration chamber, as opposed to where we used to be. So I think that's actually a positive.
And following on in this behavior question, like with the SF6 technique, the animals have a device on them, and with the sense technique, they're carrying some instrumentation below. How heavy is this, and how does it impact them? Is it a concern from a welfare issue at all, or?
Well, any of the weight in an SF6 method, and it's not particularly a lot, is on the back. So just as an aside, we had our Minister for Agriculture visit, and we used to have one of our fiberglass cows in reception with the gear on. And first thing she walked in and said, "Why's your cow got a suicide vest on?" Yeah, which I thought wasn't the ideal thing to hear from our Minister for Agriculture. The cow's not in reception anymore, I will say, but it's a very lightweight system, so has no impact. We've seen no behavioural changes with that. I guess the version of Sense we used was probably a 2 kilogram unit, which with a 650 kilo cow still isn't a lot. They know it's there, but it's not a lot. But since then, I believe that's been reduced in size and weight since then. So no, we saw no behavioural issues.
Just want to, so when we talk of behavior, it's a proxy. So we need to understand, like just what's behind it is really a like intake change driven sickness, or it's what it's about. So I think that's more important. We've done a study of the chamber. Well, typically we set a chamber in the 14 Celsius thermal neutral condition. When we did in summer, the cows entered the chamber even more actually because they were less stressed. So I think it's not a yes or no. Really depends on what factors driving and so on.
Okay, so there's a question about protocols for carbon credits. So this would be verification on farms. Are there measurement technologies that can enable verification on a farm that are cost effective and within the economics of carbon credits? Like how do we go about verification on farm when we have a mitigation strategy applied?
Yeah, so I think that's always a challenge. I think many of the protocols that are out there always have kind of an either or clause, right? You can either model this with a good estimate from experimental data, or you can try to measure it on farm. And I don't think anybody actually chooses measuring on farm, right? Because of all the difficulties. For us, that was part of the intent of some of the work that we're doing, comparing the open path laser system basically with the green feed, is this idea of, what if you do have something that you can deploy on large operations that's more of a snapshot of before and after that would, hopefully provide some more confidence, but not necessarily be something that we're hanging our hat on for testing a methodology, but just rather confirming that something worked or not, right? I think it's challenging though. I think realistically, modeling emissions makes a lot more sense for any of these markets because as already been discussed, it seems like it's difficult to figure out where the value is and who's going to pay. And if we add an expensive measurement methodology in the middle of it, it's probably not going to make it easier. So the more that we can do in more controlled environments to improve our modeling estimates, it's probably going to facilitate wider adoption faster.
Just some quick questions about the Sense technology. Like how long does the battery last? Are you measuring more than just methane? Just some practical, yeah.
So it's methane and carbon dioxide.
Okay.
So it does measure both. For the trial we ran, because we had the gear on for 5 days, we were trying to conserve battery. So we'd have 3 hours on, 1 hour off, just to try and conserve battery life. And again, I think that's probably one of the iterations ZELP will be looking at to improve battery life. But I guess ultimately, if we come to a point where, like any methodology, there's enough confidence in it, can we reduce the measurement period, which may solve battery life issues? So again, I think that's a work in progress.
Okay. There's some questions about accuracy and precision. So was it you, Joe, that maybe showed with the SF6 technique, or maybe it was yesterday I saw. Anyway, how would you describe the day-to-day variation within, say, the SF6 technique compared to a chamber or other techniques? Like, part of that variation is going to be the cow just doesn't produce the same amount of methane every single day, right? But how much of it is due to measurement technology?
Look, I think I did have a graph up that showed, everything didn't sit exactly on the line.
Mhm.
Some was a little higher, some was a little lower, and there is variation within it. I guess where we came back to with, say, the SF6 against the green feed was a very high concordance in the data. I think we were up at about 95% concordance with the methodologies, which gave us confidence that either was equally as good as each other, which then allowed us to say, well, we don't need to continue doing everything in respiration chambers when we've got a methodology that's appropriate to use in other environments.
And moving to Mutian, you showed a graph where you compared the respiration chambers to the green feed. And I think what I saw was the slope of the line. The green feed underestimated at high levels and overestimated at low levels of methane emission. Is that right? And why do you think that happens?
I don't know. That's why we call comparison, and rather than, because one can be a benchmark for the other. So, and also there's the 32 actually from 2 treatments. So this could be, as we know, when we do regression, a couple of points can drive the slope. So, which is why I want to go a little bit bigger to see whether is that true, and then further understand. And then, of course, when we aggregate to treatment level, then we actually basically smooth out most of the animal individual variabilities, and there you see the biases are really become minimal. So yeah, still ongoing looking into it.
Mhm. Okay, so we're almost out of time. I guess just quick answer from each of you. As we move forward, where do you think we need to put our resources? Like, where are the biggest limitations for robust methane mitigation work in terms of measurement? Sarah, any thoughts?
So I think some of those comparisons are really good in terms of what we've discussed. I think there can be further kind of validation of some of these other methods, that anything that accelerates this, particularly on the genetic side, the phenotyping at a lower cost, I think is really valuable, of this idea of individual animal measures with enough accuracy and precision that allows us to use it for selection purposes, I think is really important. And it's a big challenge. And so it's great to see the innovation in this space. I think we just need to keep pushing in that area of, can we lower the cost of collecting a methane phenotype to $2 a cow or something, right? That would be ideal.
Joe, thoughts?
Can't disagree with
Ditto. Nothing else? Mutian, what do you think?
Oh, I very much agree. Also, I really want to expedite the standardization again. Like I said, to have something we can all rely on to really, if you think about the AI, computer science, how fast it grows, and then we are lucky we are a little bit slower in that, in our domain. The robots, humanoid cannot feed the cows for us yet. But there's some part we can really take advantage of them. That's really something we think we can do about, and then can help us in there. Yeah, that's it.
Great. Well, with that, we'll wrap it up. And thank you very much to our 3 speakers.